Okay, hello everyone. My name is Mario. I work for COPSEC and I have volunteered for this. So the question was to present how to use Git efficiently. I wasn't sure what it exactly means, but I did come up with a presentation. So yeah, let's move ahead, and then towards the end, I'll show how I use it. So yeah, I don't know kind of the level of each of you, but if you can profit from this, I'll be happy. Um, okay, so first, what is Git? So Git is a version control system, and there will be other terms as well. So it's kind of important that we kind of understand what Git the three letters are, and we use it to manage and keep track of different versions of software artifacts. So you can have all bunch of data up there, but we use it mainly for software. Um, okay, great, thanks. People use it mostly to kind of share code and to work collaboratively and to keep track of the progress. And it's used many times in open source projects. I mean, there are also kind of not open source projects or proprietary software, but open source is kind of very frequent use for this. And I want to mention um, the the data handling. So because most of us are kind of in data science, chemometrics, bioinformatics, etc., it's probably shouldn't upload data there. So you're probably in some projects or have some type of contracts with university, etc. You shouldn't share your data there. So as far as I remember, GitHub, there are other online repositories, but GitHub was bought by Microsoft. So, ChatGPT, etc., they're learning from those. So don't upload data there. The second limitation is, for example, for GitHub, which I will explain later, is it has a 100 megabyte upload limitation. So it's kind of, the version control system uses it for software, but don't use it for data. Find another way to or cloud or whatever network drive. So what are some kind of good things with Git is you can resolve overlapping changes in code, identify those as well. You can ensure kind of disruption-free multiple contributions, either by yourself or by other people. It's very good for collaboration. So either, if you have, each one develops a part of the code and then you can test it, or, you want to share it publicly, it's kind of the right tool. And it has many nice features. So versioning is one of it. You can branch out. You can have, each person in the lab can have an own branch of the project. You can merge those together. You can resolve conflicts if, people did similar things or whatever. And you can limit access as well. Okay, so the frequent term used around Git is repositories. Sorry, let me first explain a bit more about Git and the other terms. So, like I said, Git is a version control system. Okay, this is a system. It's a software, but it's not a repository. But you may want a distant online repository. Okay, so you're developing at your own laptop or in your own server, but you want a repository where you can kind of share your work either publicly or with colleagues, and hence you need online repositories. And then we get to the terms of GitHub and GitLab. So GitHub and GitLab, they're based on Git, but they're cloud-based hosting services that let you manage Git repositories. Okay, so we have to kind of differentiate between those. So Git is, we usually use it either in terminal or with some software, and then GitHub and GitLab are where we host the projects, where we host the code. So we have this distinction. And to get Git running, you need to download it and install it. And you can use it via terminal if you have Mac or Linux, or for Windows, there are these, I showed it on the screen. You can just, download the exe files and then install it. And that means you have the Git version control system installed on your laptop. So you don't have a repository yet. Git is often, in IT, etc., is used via the terminal in so-called git bash, so the kind of commands of Git. And there are many commands. So you can see here, I typed in my terminal or PowerShell in Windows Git, and then it shows me, okay, it's installed, it's there. I have the Git bash, and there are many commands I can use. And you can see here, clone, add, move, restore, etc. So I'll show some of those later. So basically, you can use it with the Git bash, but I will show later also the GUIs, the graphical user interfaces from GitHub, which are very convenient, and you don't need to use Git bash. So you have Git installed, you can use it, and there are many commands. So the point of these commands on the slide is not to learn them, nor I think probably you may not never use them because there are these GUIs, but just to kind of give a brief overview of, you have the configuration options, so git config, the help options, init to initialize, clone to clone someone's repository, which is publicly available, or from your colleague. You have the add files, you have the commit, git commit, meaning I'll show the changes, then git status, push, pull, etc. So these are kind of the commands. There are not so many, so kind of around 20 commands will suffice to work in git bash. And now to the repository. So we installed Git, we have a local repository, meaning so we're not kind of copying the repository from a person, not pulling it, but we are kind of having our own, so we can create a local repository. We can add files to it, Python, R, whichever code you have, text files, and we kind of make our first commit. So we need Git, we need a local repository, and later we will see we also need an online repository. So again, you don't need to learn this, but just to kind of have a brief overview. So in a Linux machine, this would be you would install Git, sudo apt, with the sudo rights, you would install Git. You would create a directory with mkdir, and then you would add files to your repository, for example, Python files. Then you would add those changes to Git, and then you would commit them to some kind of online repository. And there are different stages of using it. So when you're coding in your repository, so it's just a folder where you told Git, okay, this is my repository, and you're coding. The changes which are happening are only happening local, so on your laptop or server. So with the command git add, you're moving the files into a so-called staging area. And there you're saying, okay, these are files I'm preparing to post somewhere online. And then with the while they're in staging area, they're still not in your online repository. You have to use the command git commit, meaning you're saving your changes to the repository. We're still local. And if we want to move them to the online repository for either our colleagues or publicly or to have it publicly available, we have the command git push. So git add for a certain file or all files, git commit to save the changes, and git push to push it online. The thing is, you need to be logged into your online repository. So there are also commands for logging in, but you need an online repository and you need to be logged in. So the important difference is between git add and git commit. You need to execute both. With the git add, you stage changes. You can do it multiple times. And then, for example, in IT, when you finish your work at the end of the day, you would commit, for example. So you're saving your changes all the time, for example, with add. And then with git commit, you're kind of finalizing. And then the next step is pushing those online. But as I said, I just wanted you to see those. You probably won't use them except you're working on a Linux server or a virtual machine or whatever. Okay, so version control system, we have Git, we can make an online local repository. We saw that we can save the changes, we can commit them, and then we need an online repository if we want to push them. So there are a couple options. I have listed here the two which are known to me. One is GitHub and one is GitLab. So a GitLab is popular with companies who care about privacy a bit more. because GitHub, I think they're owned by Microsoft now, and I know some companies wanted to have their own GitLab, etc. So I wanted to mention both of them, but kind of as a student, as a PhD, etc., I think GitHub is a good option. So they cost usually, depending on the type of work. So you can have a free account. It has some limitation, and then there are kind of team, enterprise, etc. accounts. The good thing with GitHub is they have these student options and teacher options. So you can have the student developer pack, and it's really packed. They have many options, tools, etc. And this is nice to use. So if you have a university email, you can apply for it. It's, I think, free as long as you have the university email. So if you were a student and then later a postdoc, etc., this will remain. So I think, this is a good option for students. I have it, as long as you're maintaining a university email, it works. And then there's GitLab, different pricing. You can, again, have a free account. It has more storage comparing to GitHub, but I think it comes down to the same. So I like GitHub because they have a nice GUI. Okay, so this was the presentation part. And kind of the go-to message from here is Git is a version control system. We have to install it in our local machines. We have to have our local code repositories. And we have different stages of pushing files to some online repository, which we have. And now I'll do kind of a live demonstration of how I would do it. So first, what I wanted to show you is I see in papers more and more often some code repositories. So some journals want you to be kind of have open source code to show what you worked with. So I think, and I also think, I'm kind of for this open access, open source paradigm. So, try to post your code. Don't post the data if you're not allowed to, but try to post your code. This is how I did it. When I have a paper, the code for the pre-processing method, etc., is available at this repository. Okay, so you would click on it, and then it opens the repository. So see, this is Mario Lovric, this is me, this is the solubility repository, and there I have a readme.md file, which explains the repository. So this is how the project is structured. This is where the data are. I did upload the data here, but the data is supposed to be publicly available. It's also from public sources, so this is okay. Or you can upload the data to Zenodo. So if I go to Zenodo, here we have it. It even has a DOI code. So this is the good thing with Zenodo. You can upload your data there and give a short description, list the authors with their ORCIDs. And there you can link it to the paper as well. So let me go back to. I always struggle a bit with these screens. Yeah, so this was the solubility repository. There you have, I had, for example, which was the best model, how to run it, etc. So you can add all of those things to the repository. So here we see two things which I think should be in every repository. This is the license and the README-MD file. When you create a repository, so this is GitHub. The cat symbol is GitHub. So README-MD explains your structure and what you wanted to achieve, etc. And then the license, it basically tells, okay, you can use this code as long as you say, I did it. So there are different sorts of licenses, but then you can just add the license there. And then you have the different folders, depending on how you did your work. I have my experiments here, results, source code. You can see the data is here. We have the CSV files. And the nice thing about GitHub, if you try to open a file, you see the structure here of the repository. So we're still in this solubility repository. You can see here, the code, and then maybe you want to have a glimpse at the data. If it's a CSV file, it will show you the data. So this is the nice thing. So you can view it online, or your supervisor or whoever. But yeah, so when you open a GitHub account, which is free, at least in the beginning, this is your kind of dashboard. Okay, and you want your new repository. Okay, so let's go with the new repository. I'll click here on new repository name. I kind of played a bit already. I'll add here KU Git course. Okay, checking. Okay, it's available. Description. This is a repository for KU seminar, for example. Do I want it to be public or private? This is a nice feature. I think depending on which package you have, you can have a limited number of privates. Add the README file. Yes, definitely. Git ignore. Git ignore is about ignoring certain type of files. So you can, for example, if you have a repository, you have your Excel files, you can say ignore Excel, and then it won't upload the Excel file. So you can use this for kind of privacy. But I do want a license. I want an MIT license. Yeah, create repository. Okay, so this is my KU Git course repository. License and README MD are in there. Okay, so this is kind of the very basic repository. The address is, let me just move this down because we don't see it here. The address is, here you can see it. It's github.com, my username, KU Git course. Okay, this is also quite convenient. Okay, back to full screen. In general, I could already add here a file. So I could go to add file, create new file. I could say this is, I don't know, recipe for banana bread. And commit changes. I'll name it recipe, commit changes. Okay, it asks me to kind of give a message, my first file. Okay, and here it asks me whether I want to commit directly to the main branch. So I mentioned branching before. So there are branches. So there is usually the main branch. This is given, but you can have kind of development branch or certain people can have their branches, etc. So commit changes. Okay, and now I see if I go back to my repository, I see here there is a file called recipe. If I enter this, it says recipe for banana bread. Okay, here is the tree structure. So I already committed something. And then I can, there are plenty of options. I see here I'm in the main branch right now. Yeah, I can add files, I can check code, etc. There are issues, pull requests, actions, projects, wiki. Wiki is good for kind of telling more about your project. There are insights. Insights are kind of, statistics, how many contributors, what commits. You can see your commits here. Okay, I see here now I had 2 commits on a Wednesday. Okay, so there are kind of a bunch of stuff which is probably more useful for IT companies than you guys. But then there is this nice option to have collaborators. So at this stage, I should mention GitHub has a mobile app which they use for authentication. So sometimes here, I want to enter kind of details of my project, and then it requests me to authenticate via the app. This is what I did now. Yeah, so you can add here people. So I'll add a colleague of mine takes his account. Add Hussein to this repository. Okay, so you can easily add people to the repo. The nice thing is if you publish a paper together, they're also listed in the repository as collaborators. Okay, let's go back to code and let's go so this is the online repository. So this is where I have my code now, my recipes. But there is an app by GitHub. You go GitHub download, and then you'll see this app. This is the GitHub GUI, and this is the reason why you don't need to work in Git Bash. Okay, super convenient. So I'll add or clone. So I could go into Git Bash now and say, please git clone this repository. Okay, but being that this repository, so I'm logged in here with my GitHub account, I can just look for my own repository, which was KU, what was it? Git, no. So I just have to find it. Second, KU Git course. Clone repository, KU Git. It's weird.
If you have another repository, KU test 0.
Yeah, but I should be able to clone here now. Clone. Maybe it didn't update something a second. It worked before. KU Git course. Yeah, it's definitely there. I can restart the app. Okay, GitHub. No. GitHub desktop. This is the app. Okay, let's try again. Add clone. Okay, you get there it is. Yeah, you just needed to see. This is the one I posted online. Okay, it's publicly available. Okay, you get course, and then here you see the local path. Mario.Lovric reps, which is kind of my folder for all the repositories, and then the KU Git course. Okay, clone. I've cloned it. I have it now local. Let's check it. I have here my reps. Let's look for this one. KU Git course. See, this is I'll open this with Notepad++. And there it is, recipe for banana bread. Okay, I've cloned my online repository. Okay, let's make changes. Okay, so you need almond flour. It's written like this, is it?
Flavor.
Well, no?
Flavor. Almond flavor.
What's written?
The product.
Flour. This, yeah. Okay, I'm saving it. Okay. And let's look at the GitHub desktop app. Okay. What I see now, here's the list of changes. And I see, recipe had changes. And here I see what? I added here, do you see with the plus? The blank line, and you need almond flour, 500 grams. Okay? Okay. And now this is kind of already added. Now I want to commit it. I want to commit it to the kind of to my repository, but I'm still local. So I'm writing here added first part of recipe, blah, blah, blah. Okay, commit to main. So this is kind of now in the commit phase, which I showed before. And now I have the options to push to origin, meaning I will push it to the online repository. I need, again, to move down a bit with the screen because of the Zoom thingy. There, okay. I'll do it like this. Okay, so there is this option, push origin, okay? So I have one commit, you see here, one commit, which I'm going to push online, pushing to origin, refreshing repository. Okay, no stashed changes here. If I go to history, we see here initial commit. This was creating the repository. This was create recipe, what we did online. And this here now is added first part of recipe. And I can see here the changes, okay? Let's check these changes. We added the file recipe for banana bread, etc. Let's go online. Okay, let's look at our online repository. Okay, recipe. And there it is. You need almond flour. Okay, so that easy. No need for git bash. I don't know about Mac. Probably works, nicely as well. But yeah, basically you don't need to kind of deal with the comments. You can do it online. If I do here a change again, here is the pen, edit this file. Okay, you need also bananas. Okay, commit changes, update recipe, commit to the main branch, commit changes. There you go, it's committed. If I go to my GitHub desktop app and I press fetch origin, so it's looking for changes elsewhere, so in the online repository, and there it says there is one commit which I can download. I'm downloading this commit. Okay, and now see, I have here a new change, the update recipe, where I added bananas elsewhere. And if I open the file locally, I would recommend Node++ to everyone. Reload it. Yes, there it is. You also need bananas. Okay. Now is the right time to mention branching. So, we say, okay, we have a product, it works, etc. And then I want to do some changes. Should I change it kind of in the main file, which is publicly available, or not? And then I would say, okay, let's do a development branch. So again, you can work with commands, but then here you have the option new branch. New branch, let's call it the development, recipe development branch. Recipe dev branch. Create branch. Okay. And this is important now. Branch is still not published, okay? I'm here currently in this branch. That means if I add here, you also need some cinnamon. Not sure if I did wrote it correctly, but then I'll save it, okay? Keep in mind, I'm in the recipe development branch, okay? I'm publishing the branch online. Okay, let's go to the repository and I'll just open the, okay. Now it says 2 branches. Okay, I can choose the main branch or I can choose the recipe development branch. If I go to recipe now, I am in main, okay? I go to recipe. No cinnamon here, okay? If I go back, I go to the recipe development branch. If I go to recipe, okay, this is weird, just a second. I didn't commit probably something. Yeah, sorry, I didn't commit my changes. Cinnamon, committed to branch, push to origin. Okay, it's pushed. I go here. Reload, there is cinnamon. Okay. Now I have to go back, check main. Main shouldn't have cinnamon. Yeah, main doesn't have cinnamon. The development branch had cinnamon. And this is how you collaborate. So if you don't want kind of the main to be ruined. And then I say, okay, I want cinnamon in the main recipe. I think it goes into the main recipe. So what do I do? There is this option of compare and pull. And I say, here it is. Recipe development branch is able to merge it into main. Okay? I write, I think it's okay to have cinnamon. Create pull request. Then it runs test. It requires approval. I say confirm. Okay, pull request successfully merged and closed. If I go here again, sorry, code, main, I'll check recipe, cinnamon is there. So I pulled the development branch into the main and now cinnamon is in the main recipe. Yeah, I can have issues. Okay, I can say new issue, title, don't like cinnamon, remove cinnamon. And then I can tag coworker, which is myself, submit new issue. Okay, and now I see there is an issue in the repository, and as a developer, I can remove this issue given by, I don't know, the Scrum Master. And then I can say, okay, no worries, close with comment. Yeah, issue is closed. I will remove cinnamon. Okay. Probably the best thing about it is returning to old issues of the code. Just have to remind myself how to get there. And this, if anyone knows, tell me.
I have a clue. I don't.
Just a what's this option to find the commits? Here, yeah. Sorry for this. Is it an insights? Commits? No. Yeah, I don't know. I don't know here now. Yeah, I guess you can just zoom in a bit. But in history, you have the history of all commits. So you could go here, revert changes in this commit. So you could return the changes. Yeah, there's also an option online, but then you can go back to old versions of the code, which is a nice feature because sometimes new code doesn't work and then you have the issue. Okay, so the last thing I want to show you is that some IDEs like PyCharm for Python, they have integrated options for Git. So if I go here to, I'll open the project which we created. For some weird reason, it needs time. This is the new version of PyCharm. I'm not happy with it. Oh, yeah, I can skip this as well. So anyhow, you have here, see the branches, the main, etc. Commit, push. This is also possible in PyCharm while writing code. I think R must have an option as well. Yeah, or you can use the git bash, and then where we are. Yeah. Always issues with this. We are in ku git. Yeah, and then you can use it from the bash git status. See your branch is up to date, etc. And then theoretically, I could yeah, comments. Yeah, okay. We could update the README MD file. And I could say here's something like signed by ML. Yes. Okay. So I could now go to git add. So I'm stashing all files, and I could go git commit. I have a message and saying updated README. Okay. There it is. One file, this change, one insertion. I had just a single line. And then I could ask git status. Your branch is ahead of origin. Okay. Meaning I did some changes which are not online. So I just go git push. Yeah, I was logged in from before, but now it's saying, where was it? Yeah, counting objects, delta compression, blah, blah, blah. Okay, let's go check online what happened or if anything happened at all. So what I did locally with the bash, I updated README MD. Probably need to Second. Okay, git course. Okay, it's pushed. Sorry, it's the other branch. Yeah, yeah. This happens to me often. So I was in the branch, the recipe development branch, and there, if I click on MD, you see it's signed by ML. This was the new addition in the branch, not in the main file. So I could go again to pull requests and yeah, create again a new pull request, etc. Yeah. So and then here you see this branch is one commit ahead and one commit behind ML. So if I go to main and go to readme MD, it's not signed by ML. Go pull request. Uh, uh, create new pull request. Just a second. Yeah, it didn't update this file. I don't know why. Yeah. Okay. Are there any questions?
So you code in Python.
Yeah.
Do you use what you showed us here, or do you use GUI within a GUI?
I use the GUI. I can show you on living example. Just check. I think. Yeah. Okay. This is a working repository. I see here the history. This student, master student, he did this repository. So this was his first submit. And then, yeah, he didn't have any changes before the first submit, but I did have some changes and they're all here. I didn't commit them yet. Or maybe another project, also a master thesis. Yeah, for example, here I see in history that this student did many commits and pushes. See here, Ivana Terzic, etc. And then I can see what I added from changes. I did it in code. And here you see, so for example, I changed the paths in the file so I could load the data. So when I do the changes in the code, it registers them automatically if it's a repository. Was that
Yeah.
Yeah.
Yes. I know both within GitLab and within RStudio there are support for
Git?
Yeah.
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 Through those interfaces.
Yeah. I think it's I use it for even kind of writing files, so like TXT files, or I don't know. At some point, I used it even for papers, but then I switched to Overleaf, so no need. But it's also kind of nice for other collaborative work.
Yeah.
Online questions
Online
or
questions.
group?
Ivan has put a lot of things
okay.
in the chat.
Yeah.
Something with the privacy thing.
There's also Codeberg, okay, which is a German GitHub clone, okay. Okay, this is good to know. Thank you, Ivan. Source Hut, Netherlands. Okay, so we have Codeberg and Source Hut, which are European alternatives. This is good to know. I haven't explored those. Sorry, Ivan. Yeah, I didn't see. No. Yeah. So Ivan posted things online. Yeah. So what I mentioned before, Ivan also mentioned here is git ignore. So the PYC files which we have here, these are files which are not needed. They're kind of happening during execution. So you can add them to git ignore and say, don't upload these PYC files because you basically don't need it. So it's these PyCache files. And what else did Ivan comment? Yeah, there are conflicts. I feel like when there are conflicts, when you're working with multiple people, sometimes GitHub, the desktop app, is maybe not so intuitive. But yeah, there are options to remove conflicts Yeah. Yeah, so I think it's useful for anyone to click on what Ivan posted here.
Yeah.
Yeah, I don't know if this was kind of up to Rasmus' expectations on using Git efficiently.
I think it was. I think this is a great overview, and I would just encourage everybody to use this, especially if it's just for publishing your source code.
Yeah.
If it's just for that, then it's still something where there is another server which is gonna survive beyond KU server systems, which will take care of the code, and codes are usually not. There's no GDPR, no security. That's publicly.
Yeah, you can add the public license and that's it. Yeah. So you can see I have, for example, 53 repositories. I have there is this option to star a repository. So I don't know, let's say you are into, and this is probably the best thing, which I should mention. I don't know, near infrared food. Check. No, probably not. Maybe say just infrared spectrum. There are people who did stuff, and there is a very high probability that what you're doing right now, probably someone has already done and published.
Yeah, that's science.
Yeah. So there is this guy, he did R functions for the chemometric analysis of spectra in R. There he is, Brian Hansen. Maybe he's even Danish. No. Yeah. So this guy did a repo called chemospec. It's R. You can install it, blah blah blah, and then I can start this. So it's kind of my favorites. So this is very neat. And then you can sometimes I'm looking for I don't know, code which I think should work. I don't know, low spectra. Let's check that. And then here you see you want it in MATLAB language, MATLAB. There's this guy who did MATLAB UVVis. Let's check his code out if he's writing nice code. Yeah.
The documents.
Yeah, the documents. Yeah, this is also one of the reasons for documenting. You want others maybe to understand and use and cite you.
Yeah,